Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So today we're going to check on a problem which is from 2024 Apmo. Let ABC be an acute triangle. Let D be a point on side AB and E be a point on side AC such that lines BC and DE are parallel, which means we can simply find a triangle ABC here and find DE here. Let X be an interior point of BCED. So we can assume here is a point X. Suppose rays DX and EX meet side BC at point P and Q. So DX and EX. DX and EX meet line BC on point P and Q, respectively, such that both P and Q lie between B and C. Suppose that the circumcircles of triangle BQX and the triangle CPX intersect at point Y, which is not X. So then prove that points AXY are collinear. Okay. So the problem set is quite easy, which is that we know DE is in parallel with, in the triangle ABC, we find DE is in parallel with BC. And we know X is a point that inside the BCED. And we connect DX and EX, extend the DX and EX meet BC on PQ respectively. And then we find the circumcircles of the triangle BQX and the triangle CPX. These two circles intersect on 2 points. One point is X and another point is Y. So if you look at this one, roughly say that the circumcircle looks like this, right? And for this one, the circumcircle of this triangle look like this. Right, so they probably meet on this point, Y. Right, so I'm trying to draw that circle. Right, this is one circle, and for another circle, oh wait, yeah, it's difficult to draw, so I don't know, probably here is Y. Let me see. Yeah, it's difficult to draw, right? Let's just redraw the figure. Forget about the circles. Let's just think, we don't really need that circle in this problem. Let me explain why we don't need it. I mean, we don't need to draw it. So we can do it like this. For example, Okay, now we have point D, point E, point X, P is here, Q is here, and okay, just to think about that, we have a circle, looks like this here, right? And another circumcircle looks like this. So these two circles meet probably on this point, let's call it Y. Then we want to prove that AYX are collinear. Basically, what we have here is that we know BQXY are cyclic, and we know CPXY are cyclic, right? That's what we know here. And we want to prove that AYX are collinear. Think about that BQXY are cyclic and CPXY are cyclic. That means XY is the radical axis of the circumcircle of the triangle BQX and the CPX, right? So XY is radical axis of circle BQX and circle CPX. Right, this is a key point. That means we just need to prove because we want to prove that AYX are collinear, which means that we want to prove A is on this radical axis, which means that we just need to prove A has the same power to the circle BQX and to the circle CPX. Then we solve the problem, right? Then we can think that we have the circle BQX intersect the AB on a point, let's call it F, right? So now we have BQXYF are cyclic. And also, for another point, that the circle CPXY intersects the AC on another point, let's call it G, right? So we know CPXYG are cyclic. Then we can see the power from A to the circle BQX would be AF times AB. And the power from A to the circle or circumcircle of the triangle CPX is AG times AC. Right? If A is on the radical axis, that means these two powers are equal. Right? Which means that we can prove this equation to prove that A is on the radical axis. Now the problem is that how can we prove AF times AB equals to AG times AC, right? How can we prove this? And notice that because the triangle AFG and the triangle AFG and triangle ABC have the same angle A, and if AF times AB equals to AG times AC, that means triangle AFG is similar to triangle ACB, right? Which means we just need to prove this one. And if we want to prove this one, we just need to prove angle AGF equals to angle ABC, right? Now the question is that what is angle ABC? Because DE is in parallel with angle ABC, so we know that angle ABC equals to angle ADE, right? This one equals to this one. And basically we want to prove that angle AGF equals to angle ADE, which means we want to prove that FDEG are cyclic. So we want to prove FDEG are cyclic. Right? And we already know that B, Q, X, Y, F are cyclic. That means B, Q, X, Y are cyclic, which means the angle YXE equals to angle, let's do another way. Yeah, let's do another way, because we still want to have this angle, right? We want to find the angle related to the angle FBQ. So we can actually connect FX here. Right, think about what we have here. We know that B, Q, X, F are cyclic. That means the angle FXE equals to angle FBQ, which is angle ABC, right? Why I want to, we already know that B, Q, X, Y, F are cyclic. Why I have to just choose these 4 points? Just because that we want to find the equivalent circle to the angle ABC, which is angle FXE here, right? So we know that angle ABC equals to angle FXE. And also angle ABC equals to angle ADE, which is angle FDE. That means angle FXE equals to angle FDE. So we got FDXE are cyclic. Right, we got FDXE are cyclic. That is saying F is on the circumcircle of the triangle XDE. And you can see this is a symmetrical problem. That means G must be also on the circumcircle of the triangle DXE. But we can prove that easily, which is that we know angle ACB equals to angle. So here let's connect the GX, right? Because angle because GCPX are cyclic, so the angle ACB, this one, equals to angle GXD, right? Equals to this one. So angle ACB equals to angle GXD. And we know that angle DE is in parallel with BC, so angle ACB equals to angle AED equals to angle AED. Therefore, angle AC, the angle AED equals to angle DXG. AED is DEG, right? So angle DXG equals to angle DEG, which means DXEG are cyclic, right? So we got FDXE are cyclic and DXEG are cyclic, which means FDXEG are cyclic. Right? These 5 points are cyclic. That means FDEG are cyclic, which means this angle, the angle AGF equals to angle ADE equals to angle ABC, which means the triangle AFG is similar to triangle ACB, which means AF times AB equals to AG times AC, which means A has the same power to the circle BQX and circle CPX, which means A is on the radical axis of these two circles, which is a line XY. So A, Y, X are collinear. Okay. This is Asian Pacific Math Olympiad. I don't think this is a very difficult problem. It's so straightforward. Yeah, it should not be an international level problem. It's it's even easier than a state level problem. Anyway, I hope you like this video. See you in next one. Thank you.